All right, so today we're looking at 1.2.7. What if there are multiple outcomes? And so yesterday we talked about adding fractions with different denominators. For example, if we added 1/3 plus 1/4, we would have to find a common denominator that works for both of these fractions. 3 and 4 both go into 12, and so I would make 1/3 4/12 and 1/4 3/12. So we're going to talk about how we can utilize that to help us figure out if we have multiple desired outcomes. So, what do you think compound probability means? Think about that word compound. If I have a compound word, how many words are in my compound word? So, compound events or compound probability is referring that you have more than one desired outcome, right? Just like in a compound word, you have more than one word in it. And so here it's going to be asking, like, what are the odds of landing on a red or a purple spin on a spinner? So notice it's talking about more than one event, red or purple. It might also say red or purple with the word either. It's like either red or purple. So first we're taking a look at the spinner on the top right of the screen. And we have 5 different chores. We have raking leaves, doing laundry, cleaning the bathroom, cleaning the bedroom, and vacuuming. I don't know about you guys, but I like raking the leaves the best because then you get to jump in the big pile at the end. And so here we're talking about Thomas. And Thomas, each day, spins the spinner to decide which chore he's going to be doing. Now, this spinner has raking leaves and doing laundry as the same size. Okay, so these are the same size slices. And then the sections for clean bathroom, this one right here, and vacuuming are also the same size. So what is the probability that Thomas will spin do laundry? Now notice it doesn't give you a fraction for doing laundry like it does for cleaning bedroom and vacuuming. So you guys have to use what you know about these two fractions to figure out what clean bathroom would be, and then maybe figure out how many slices you want to divide this whole spinner into. Maybe you can find a common denominator, and that will help you figure out A. Go for it. All right, so you should have ended up with 1/12 because 3 and 4 both go into 12. And so you could divide the spinner into 12ths. This here would then be 3/12. This would also be 3/12, right, because they're the same size. Clean bedroom, 1/3 would turn into 4/12. And so far I have 3/12, 3/12, and 4/12. So I have a total of 10/12 covered. And then I have my 2 slices left. 2/12 divided by 2 would be 1/12. Because I'm looking for just do laundry. So that's how I get my 1/12. Now we're looking at the bathroom because Thomas hates to clean the bathroom. When he spins the spinner, what is the probability that it will not, keyword not, because I don't want to land on it, land on clean bathroom? Explain how you found your answer. Take some time, answer this one. All right, so you should have ended up with 3/4 because clean bathroom is the same size as vacuum, and so it's 1/4 on the spinner. And if it's the probability of not landing on 1/4, you would do 1 minus 1/4 or 4/4 minus 1/4 and end up with 3/4. You also could have changed the whole thing into 12/12, subtracted that by 3/12 and ended up with 9/12, which would go into 3 out of 4. All right, so now we're looking at the spinner either landing on clean bedroom or raking leaves. And so first off, we're looking at what is the probability of cleaning the bedroom and the probability of raking the leaves. So right away, the probability of cleaning the bedroom is 1/3, tells us that right here. And then the probability of raking leaves is 1/12, right? We figured that out in the first problem. And so if the probability that we will either be landing on bedroom as 1/3, and the probability of landing on raking leaves is 1/12, then how could we write the two outcomes as one single probability? Okay, so how could we add these two outcomes together and come up with a single probability? Go ahead and try it. So you should have ended up with 5/12. Again, if we were to divide this whole thing into 12 pieces, then this 1/3 would turn into 4/12, right? If we multiply by our big one, 4/4, 1 times 4 is 4, 3 times 4 is 12. So when we have 4/12 plus 1/12, we'll end up with 5/12. Now we're looking at 121. So teacher lets her students borrow pens and pencils on a day when they have a quiz, and she has a paper bag containing hundreds of wooden pencils, mechanical pencils, and blue pens that students randomly draw from. Stuart forgot his pencil, and it's quiz day. Come on, Stuart. So his teacher tells him that 1 out of every 3 students who reaches into the bag and pulls out a wooden pencil, 2 out of every 5 students pull out a mechanical pencil. So 1 out of every 3 wooden pencil, 2 out of every 5 mechanical pencil. The rest of the students each pull out a blue pen. So if Stuart reaches into the bag without looking, is it more likely that he will choose a wooden pencil or a mechanical pencil? Explain your thinking. So here you shouldn't have you should have gotten that it's more likely to get a mechanical pencil because 2/5 is greater than 1/3. And we could figure that out by finding our common denominator. 5 and 3 both go into 15. And so then you could change the 2 to a 6, and then you could change the 1 to a 5, and 6/15 is greater than 5/15. So that's how we get that answer. Next, we're looking at how can you describe the probability that Stuart will put some kind of pencil, either a wooden pencil or mechanical pencil, by using the probability that you already know. So again, we're going to add these two probabilities together. So I'm going to take my 2/5 and my 1/3 and add them together. Change them to 15th. We said 6/15 and 5/15. Add those together, we get 11/15. Then it says Felicia was trying to find the probability that she would pull either a wooden pencil or a mechanical pencil out of Miss Guyan's bag. That's what we're going to go with. I think I need to combine the probability that I will get a wooden pencil with the probability that I will get a mechanical pencil, she said. So she set up the expression and drew a picture. Here she has 1/3 plus 2/5, and she ends up with 3/8. Is this correct? Think about what we did yesterday adding fractions. Can you just add across the top and add across the bottom? Explain why or why not. All right, so you should have gotten that. No, the 8 parts do not each represent the same portion. So again, we'd have to find that common denominator. So now you're going to discuss with your team, or if you're by yourself, how would we find that sum? Talked about it a little bit on the last slide. I jumped ahead, I apologize. But how do we find that sum? So you should find it by doing 5/15 plus 6/15. And that'll give you 11/15. All right, so it's all about making that common denominator. Next, we're looking at Steve shuffles a deck of 52 playing cards and starts to turn them over one at a time. Turns over an ace, a 4, and a jack. So using this E-tool, we can access all the cards in a standard deck. Or if you want to grab a deck of your own, maybe you could try this out on your table. So how many cards are left in the deck? So I've taken out an ace, 4, a jack, and there's 52 in the deck. So how could you figure out how many are left? So you should have gotten that there are 49 left, right? 52 minus 3, that'll give you 49. That says how many remaining cards are aces. So you got to think about how many aces are in a deck. Well, there's one for each suit, and there's 4 suits, so there's 4 aces. And if we selected one, how many do we have left? You should have that we have 3 left. Now, what is the probability that the 4th card will be an ace. So let's see, there are 3 left out of 49. So what would my probability be? You should have gotten as 3 over 49. 3 is your desired outcome, aces, and then 49 is the total number of cards left. Final question. Instead of getting an ace, he gets a 2 as the 4th card, and the 5th card is a 5. What is the probability that the next card will be a king? Well, where's this king coming from? So if we draw 2 more cards, 2 and a 5, we have to subtract 2 from 49 to have 47, right? So what is the probability of getting a king on the next draw? So you should have gotten that it's 4